Hey everyone, and welcome. I am excited to share with you today an introduction to the fascinating world of multimedia architecture. In our increasing digital lives, multimedia, the seamless blend of text, image, audio, video, and animation, powers everything from the video we watch to the games we play and the presentations we create. Understanding how these systems are structured is key to building engaging and effective digital experience. So buckle up as we dive into the essential components and design that makes it all work. Let's start with the basic. What exactly do we mean by multimedia? As this last slide highlights, it's the integration of multiple forms of content. Think text you read, image you see, audio you hear, video that move, and animations that bring things to life, all combined into a single cohesive digital experience. Multimedia isn't just about having different elements, it's about how they work together to deliver information or entertainment in a more engaging and accessible way. Think about how a news website uses text alongside the image and videos to tell a story, or how an education app combines interactive element with audio and narration to enhancing learning. Here we can see multimedia architecture, the real-time structure which contain different layers such as application, media management, end-to-end control, storage subsystem, databases contain standalone server, networks, and media application. This is the full architecture of multimedia. Zooming a bit, we can see that multimedia architecture is really about creating structure framework for this complex system. It's not just about putting different media together, it's about ensuring performance, that things run smoothly and without lag, scalability, that the system can handle more user or more data as needed, and reliability, that the system works consistently whether it's a simple application on your phone or a massive streaming platform like Netflix, every multimedia experience relies on a well defined architecture. These slides give you a good overview of the key aspects of multimedia architecture. Now, components of multimedia architecture. So, what are the building blocks of multimedia architecture? These slides break down some of the essential components. First, we have capture device like camera, microphones, and scanners. Then there is a storage media, HHD, SSD, cloud storage, processing units such as CPU, GPU, DSP, communication network, LAN, MAN, and 5G, output devices, display, projectors, speakers, software tool, editors, encoders, and players. Underlying all these are various software tools, editors for creating content, encode for preparing it for distribution, and players for viewing it. Now the component of multimedia with image. This image provides a nice visual representation of this different layer working together with the multimedia system. You can see how each component plays a distinct role in overall performance and process. Expanding on that, this slide presents a layered view of multimedia systems. We can see different stages starting from the content creation layer where the multimedia is actually made. This then moves to the storage and retrieval layer for managing and accessing the data. The distribution layer handles how the content is delivered to the user, followed by the presentation layer, and application layer is the user facing part, the usual actual software or platform we interact with. And finally, the control layer manages the overall flow and interaction within the system. The multimedia system architecture diagram summarizes how this different layer and component interact. As we see in the previous diagram, how really the multimedia is structured There are the components here. It illustrates the flow of data from input all the way to output, often highlights the various devices, software, and network paths involved. Understanding this diagram is incredibly useful for grasping how different parts of the multimedia system depends on each other for thinking about how to design systems that are both scalable and reliable. Centralized multimedia architecture. Now let's look at some common architecture pattern. First up is the centralized multimedia architecture. As the name suggests, in this model, all the data and processing happen at a single central location, usually a powerful server. This approach can simplify management and control, making it easier to oversee the entire system. However, it also creates a high dependency on the server's uptime and performance. If the server goes down or gets overloaded, the whole system can be affected. This type of architecture is often suitable for small scale applications like a single kiosk based learning module. Here are the aspects of multimedia. This image gives us a visual contrast to the centralized approach we just discussed, hinting at the idea of distribution. In contrast to the centralized model, a distributed multimedia architecture spreads its components across multiple locations. This offers several advantages, including better scalability, the ability to handle more user and data, and improve reliability, as a failure of one more component doesn't necessarily bring down the entire system. However, this approach introduces complexities in terms of synchronizing data, ensuring consistency across different locations. Cloud-based multimedia platforms like cloud gaming devices often utilize distributed architecture. Now, the client-server model. Another very common architecture is the client-server model. Here, a central server stores servers the multimedia content, while client devices like your computer or phone request and consume the data. This is the backbone of many web-based applications, allowing for efficient resource sharing. Think about how YouTube works. Their server stores millions of videos and your device acts as a client requesting and playing the videos you choose. Of course, this model relies on efficient networking to ensure smooth delivery. Now, peer-to-peer architecture. Finally, we have peer-to-peer architecture. In this model, there is no central server. Instead, devices communicate directly with each other. Each device or peer act as both as a client and server, changing resources directly. This can be very efficient for the tasks like file sharing and collaborative application. Comparison table of architecture. As we studied different architecture designs like centralized, distributed, client side, and peer to peer architecture, here we are comparing all of them on the basis of scalability, reliability, complexity, and with their example. First one was centralized. It has low scalability, low reliability. Example as standalone system, distributed, have the example cloud service, client server, like we see YouTube, and we are playing a video on our YouTube. So it is client server based. Peer to peer is BitTorrent. Now, what are the data types used in our multimedia? First one was text, static content, and metadata. What is metadata? Data about the data. Audio like voice, music effect, image we have photos, diagrams, video, moving visuals without sound, with or without sound. Animation stimulate movement of images, 3D models, virtual environments. These all are the data types of our multimedia architecture. So, as we see the multimedia data types in our previous slide, we can have the five formats for their multimedia data types. First one was text, so TXT, doc, HTML. Audio we have MP3, WAV, EC. Image are the most famous JPEG, PNG, GIF. Video we have MP4, AVI, MKV. Animation we have GIFs and FLVs. Importance of choosing the right format for the right data types. Now, compression in multimedia. To reduce file size for storage transmission, lossy versus lossless comparison. Audio we have MP3 for lossy and FLAC for lossless. Image we have JPG which is lossy and PNG is lossless. So here are the comparison between lossy and lossless. For the audio and image video we have this comparison. Impacts quality and performance on the basis of lossy and lossless compression. Here are the codecs and container, like example are MP4, AVI, compatibility, and choose the based on your application need. Here are the key insight and takeaways. You can go through this. Then we have future trends in multimedia. We know that it will going to use an AI and machine learning and cloud-based AR VR. And next, we have the summary. So go through this. Have discussed all of these points. Question answer, feel free to ask. So as we have seen, multimedia architecture is a diverse and a crucial field. Understanding these different components and models is essential for anyone involving in creating, delivering, or managing digital media. There are many other fascinating aspects, and we can create more videos about it. And I hope this introduction has given you a solid foundation. Thank you for watching. Just please like and subscribe my YouTube channel. Love you all. Bye.